So let's talk a little bit about me, who I am. I do pretty much everything. Right now, I'm the CTO of Alacrity, a legal tech startup. I've taken various CTO positions in the past. Many of them were WebRTC related, and that's where I draw my experience from. I've been working professionally on WebRTC for over 3 years. Not lately though, so I'm not that fresh on the details, so don't geek out on me. I got a few, I've done a lot of stuff in open source, over 40 packages on NPM, probably 50 by now, and a lot of community work back in my hometown in Greece, where I came from. I've been in London since October 2017. So what we're going to see today is basically, I'm going to give you a brief intro into WebRTC, what it is, how we use it, and where it's useful. We're going to have a quick look at how you can build a WebRTC application, and then we're going to look at the service solutions which are necessary for you to get started quickly. Before we get into that, how many of you have developed a WebRTC application? Cool, that's very cool. Because it would be a very boring talk for the people that have. So, what is WebRTC? WebRTC stands for Web Real-Time Communication. And what it basically does is adds a stack on top of the browsers that enables the browsers to communicate between them in real time using audio, video, and data. It is free and open source. It is supported by all modern browsers. Asterisk there, I'm going to come back to that. And it's been live since February 2014, when the very first cross-browser connection between Chrome and Firefox happened. And ever since, it has been overhyped. And right now, we are at the stage of WebRTC where we have made some realizations. I'm going to talk about that later as well. Now, in terms of browser support, Chrome and Firefox were the pioneers of WebRTC. They together wrote the spec and implemented it. Opera followed suit, Internet Explorer a little bit later. Safari claimed to support WebRTC on last year, on September, October. However, the implementation is lacking and it's not completely up to spec. You're going to have a hard time, but it's not impossible. Now, in terms of features, like I said, you have real-time voice, video, and data. It is peer-to-peer, which is very interesting. So you can have a peer-to-peer connection between two browsers, two clients, without any server being involved as far as the communication part goes. And it uses state-of-the-art codecs, the VP8 now being upgraded to VP9, which are very modern video and audio compression protocols that offer us a very optimized experience. Now, like I said, there was a very big hype. There was the wave of WebRTC. We can do so many things on WebRTC. So naturally, thousands of startups started. Amongst them, I used to work in a couple of them. When the dust settled, the most startup types that found application with WebRTC were the verticals and the niches, primarily in health, legal, and services, anything that would connect an expert user to a non-expert user, doctor to a patient, or for legal advice. Right now, we are at the sobering stage, where all of this first wave of startups really crashed on the windshield and have been wiped out with a windglass. And we, I guess, as a whole, the community as a whole now really starts to understand the true value of WebRTC and how it can be used without the hype. What opens up new opportunities is the Safari support, which is going to get better, and namely having WebRTC on our iPhones. That is going to be revolutionary, because we would just open the Safari and we would have a real-time application there. Again, for very niche and vertical stuff, but not to say that it's not used in the mainstream. So Google Hangouts allegedly uses some parts of that technology, but not entirely. So what was the revolutionary part about WebRTC was that for the very first time in the history of the technological industry, we had a technology that was free, and it didn't have any additional costs for us to deploy a real-time platform. Up to before the WebRTC came out, we only were able to do real-time through proprietary software. So anybody that did real-time had their own proprietary software, either they be Skype or anything that would require us to install a browser extension or something else into our browser and PC in order to make a real-time communication. WebRTC really brought down all the barriers. It really lowered the barrier to entry to real-time communication. Anybody on the internet could make their own real-time communication application with a very high standards. So that was basically what created the hype, and that's basically the offering of the WebRTC technology to the masses. Now let's look at the ugly parts. You have a cheap start, as we're going to see later in the presentation, but a very expensive ad game, and I'm going to explain exactly what that means again later. You have a very costly development. Imagine that as a developer now, when you're developing a WebRTC application, you need to have two ends. That means two browsers. They need to connect with each other. The whole process is not easily automated in terms of testing. There are not proper and adequate tools to automatically test a WebRTC connection. Has a connection been established? Can the one end see the other end? Can the one end hear the other end? And the biggest hurdle of them all are the connectivity problems. Depending on your vertical and where your clients and customers are, you are going to experience anywhere between 3 to 15% of lost connections, simply due to the fact that your customers or clients may be behind a corporate or an educational firewall that will not allow WebRTC to establish a connection. Further adding to that problem is the fact that for reasons that were justified at the beginning, WebRTC does not use a fixed port. It uses any random port beyond 1024, which are the privileged ports, up to 65,000, the very end of the ports, 500, something. And that makes it impossible to set any rules on your firewall to enable WebRTC, basically. So that has been the biggest hurdle in establishing your business. And imagine in some businesses, a WebRTC call is cheap. For instance, I am a debate startup where people come in and debate. That's something of a low cost, but imagine the case where you have to get medical advice, and every call that you are about to make will cost or make your company hundreds of dollars. Then every connection matters, and that is the biggest challenge WebRTC implementers are facing. How WebRTC works. So we'll go through the following into the inner workings of WebRTC, rather not inner, outer. So there's an API. We're going to view what we can do with that API on the surface. There is the handshake of a WebRTC call, how a WebRTC call is established, what it requires in terms of services, orchestration, and everything, and what WebRTC requires for as services in order to establish a connection and retain it. So, WebRTC, we basically get 3 new APIs. We have the Get User Media, which acquires audio and video from our browser. So that is the API we're going to use to launch the Give Me Permissions dialog, allow this website to give permission to your microphone, to your camera. We have the RTC peer connection, which is establishing a connection with the other peer and exchanging video and audio streams. And we have the RTC data channel, which is for data communication. Now, let's spend a few minutes on those and how we can better utilize them. So don't think of WebRTC as a way to communicate with another person, all right? Think outside the box. This API gives us access to our client's microphone and camera. What we can do with those two devices is limitless, and it does not necessarily mean that we need to establish a connection. We might as well perform identity verification. We might perform, I've seen karaoke applications being done with WebRTC. So many people get in and you can have a party. There are no limits to that. So don't restrict yourself into thinking that WebRTC is for 2 people to communicate. It can be used for anything, for any application, scanning a barcode, whatever. Similarly, RTC data channel can be leveraged as a higher efficiency communication than WebSockets because it communicates in a binary diagram instead of text that is WebSockets. That saves you an overhead of about 20% in the data exchange, and it's faster. All right, now I need whatever attention you have left if you care about that. Here are the actors. We have one peer and we have a second peer, and in between them we have the STAN and the signal server. There's a third server, but for simplification I'm omitting it. The STAN server, what it does basically is tells us what is our IP, okay? Pretty much every client connected to a Wi-Fi has a local IP address and is behind a NAT, network address translation. So if you see your IP of your computer, it's going to be 192.168, blah, 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 blah. It's a local IP. So what is my internet IP? How do I know that? I have the STAN server to ask, hey, what's my IP? That's your IP. Easy as that. Signal server is something that you have to implement, which the purpose of the signal server is to signal between the 2 peers. So as we're going to see now in the workflow, I have to communicate my IP and my connectivity status to the other peer. This happens through the signal server. So that can be a WebSocket-based solution, REST-based solution, doesn't matter. Most of the implementers do it in WebSockets. So let's go through what needs to be done in order to establish a connection. Like I said, the very first step is for peer 1 to ask the STAN server, what is my IP? And once the first peer gets its IP, it then produces what we call candidates, and those candidates include information about my connectivity and about my possibilities, what codecs I support, how you can connect to me and stuff like that. The SDP is the session description protocol, which is basically a schema defined, it's a standard that again relays what are the capabilities of my client, both from a perspective of codecs, what video codecs I support, what audio codecs I support, and what is my connectivity. And I communicate that to the second peer through the signal server. Peer 2 in turn asks for their IP and responds with their SDP signal. Now, with both peers having each other's SDP they start producing the candidates. Candidate is a possible candidate for us to establish a connection. So what a candidate says is that hello, this is my IP. I give you my internet IP. I give you a port, and I give you a protocol. It can be UDP preferably or TCP. All right. So any one of the peers produces anywhere close to 15 to 20 candidates, and those candidates get communicated via the signal server, and connections are being tried, and then we have a winning candidate where we have an established connection. So this whole process basically is called NAT traversal, and as you can see, it incorporates a lot of pre-established protocols. For instance, SDP comes from VoIP, from the VoIP industry, as well as the candidates, as well as the ICE protocol. So what WebRTC did basically is take all of these technologies already out there in the market and the industry, wrap them together, put them in a nice ribbon, and package them as web APIs. And that is how, in very layman terms, a WebRTC connection is established. Now, here is where I explain the missing server, which plays a very significant role. I already explained the signal, I already explained the stan. Then there is the turn server. The turn server is the heavy lifting part. The turn server basically can act as a relay, as an intermediary between the two peers. If for any reason a connection cannot be established between the two peers, the fallback is to try a connection through the turn server, which is basically a media relay. You can imagine it like that. A turn server would also be obligatory if we're doing broadcasting. So we have one speaker and multiple receivers, or we want to do a multi-user chat room. That is when you need a turn server. Naturally, turn servers are the most expensive services there are out there in every respect, hardware, software, network. We are talking about the most bandwidth demanding operation you can do as a service, streaming video and audio, all right? There's no more demanding bandwidth-wise operation than that. And at the same time, the turn server has in real time to transcode the video streams and stream them on the fly, all right? So we're talking about enormous CPU and RAM requirements, and naturally it's they're the most expensive pieces in our infrastructure. Now, of course, we don't have to have all of that in place. This is a very intricate infrastructure that needs to be in place. We can start off the bat by using publicly available services out there. Google has done a lot of work towards that end, so it gives you, it doesn't give you basically, you're going to have to hack it. So if you go on Google's WebRTC tests, those tests have to use a stan server, or they have to use a turn server. So if you do a view source and check out where those are, you can use them to hack your own prototype. But when you want to get serious, when you're going to do it that professionally, the very first step you're going to do is use a third party to provide the infrastructure for WebRTC, okay? And then naturally, as your company succeeds and you grow, and those costs become significant, the only way, unfortunately, to reduce them is to move them in-house, and that is a gradual process that will be done over time, and we'll see how challenging that can be. Long story short, those are the providers. Don't waste your time looking anywhere else. TalkBox and Xerxes have been there since day one that WebRTC came out. TalkBox is the one-stop shop where basically you get the whole infrastructure. You just connect with their API, send them who needs to connect with whom, and everything is handled and managed by TalkBox. Xerxes is more of an a la carte service, so you can go to them and say, all right, I have a stand service, I have a single server, I just need the 10 server from you, or any other single piece of infrastructure. So depending on the way you want to approach your implementation, you may start with services, although I can't think of why, but it's there for you to see. Now there are other providers. Video, I used them once. I remember back in the day they had a better mobile product, but that's like 3-4 years ago. Things changed. I feel like they've stayed behind, and TalkBox really has eclipsed them. Twilio, WebRTC, I haven't even seen them, and the rest you can check them out from the URL that I provide below. So again, WebRTC, revolutionizing technology, lowers the barrier to entry, provides real-time communication to the masses at very low cost, supposedly. It's better suited, as we've seen out in the wild, by very vertical and niche applications, like we said, healthcare and stuff. Costly development, it's not only the fact that you have to set up a very elaborate test setup case where you've got multi-browsers, probably different scenarios. It's also that you're going to have to deal with the WTFs that happen with such an experimental technology from time to time, and debugging it is difficult. So this is going to cost development time like 1.5 to 2 times more. Very costly infrastructure. So you get started with TalkBox, and your monthly bills will be $200, $300, $500, but you have no users. The moment you start having users, and if you're starting handling multiple real-time connections concurrently, that's when the bills will start going vertically up, and it's going to become a very, very significant cost for your company. And last but not least, we have the connectivity risks, which basically reduces your quality of service that you provide. There will be dissatisfied users, and there is nothing you can do about it. The best you can do is just to prepare their expectations, basically tell them that, pal, you got no chance there. Maybe try to change the browser or move out of where you are, and that's the only thing you can do, because there's no other way. And that was it. Big round of applause, please.